Hey, it's Kiet here, and I'm doing another architecture kind of walkthrough of Onlook, and this is Onlook. Um, we um, we allow you to do a design, kind of a Figma design experience. Here you can see the side panel here, except for this is happening on your actual React app, and so everything that you're doing here is corresponding to a live running app, which you have in code. You see that I just flipped these, and if I flip them again, they will be flipped in code, and so we are doing it in real time. Um, it is getting to be a pretty complex piece of software, and I want to walk through kind of some of the decisions, kind of where things live, and hopefully this will be a beginning of kind of untangling this mess, or have someone be able to onboard more easily to the code base. By the way, we are fully open source under Apache 2 license, and so a lot of our contributors might find this useful. So we will start with the kind of the root here. So this Onlook is an Electron app, but it is architectured under a monorepo, and we have a lot of packages and plugins and scripts and all of that. But as far as the Electron app is concerned, it is under apps/studio right here. So this is the beginning of the Electron app. If you are not familiar with Electron, it is a desktop app technology. Well, not specifically just desktop, but mostly desktop app that has a few components. So one component is this browser window, which we're seeing here. And this is a React app that is actually running on a Chrome web page. So you can see that you might be familiar with this. It is actually all HTML all the way down. And the other component of it is a Node server. So the Node server runs like a server, and it serves this browser window. So this is very much a React web app. And the Node server allows us to do a lot of file system access, and everything in the Node server lives under this Electron/main folder. And this is the entry point to it, which is kind of where the app all starts. This is one of the first things that run when you run the app. What we care about is this kind of main window here that is being created. So one of the things that it's doing is on startup is creating this browser window, and that browser window corresponds to this UI here. So this UI, the browser window, communicates with the main Electron Node process through message passing, and you'll see that kind of in various places in the code. Let me give kind of a quick example. We'll look at this code folder here, and we'll just look at files, I think. And so here we're still in the Electron Node app, and one of the functions here is read file, which does what it says. It reads in the file from the file system given a path and passes it back in string format. So this gets called quite a lot to read in a file, and this is what we use to read in the React code that is corresponding to this element, for example. So if I hit open cursor, we're able to find the code right there. finds the actual line of it, and it leverages like the node file system access to read that code. I'll move my head here that you do not see. The main listens to a lot of these events from the React browser, and then when it does something, and it returns the result. So one of those is reading stuff like the file and code. So that's the main. Let's talk about the more complex part of the application, which is this React app. So all of the React code lives under studio/source, and it's kind of structured like a single page web app. And so you have, the beginning of the entry point of the app right here that has a bunch of stuff in it. Mostly, it has routes. So we're using a custom router that is like mimicking this kind of routing behavior based on a state. So this is kind of the entry point of the actual UI itself. So when a route is editor, we open the editor, which is where we are right now. And if I click this, all it does is set the route to be projects, and it goes to project. And that's how we navigate around the app. And so we care about this editor. And one of the things I want to talk about today is how the editor itself works. So this is kind of representative of this page here, which has a canvas, which is this part right here, a resizable panel that is actually a layers panel, which is this right here, resizable, aptly named, an edit panel, which is this edit panel. It has a chat, which we would not talk about too much right now, and a toolbar, which is right here, and a top bar, which is this here. And honestly, I should put this top bar at the top of the code, but I won't because I'm scared. So that's everything. Actually, I do want it here because hierarchically, I do want it to show up over everything else, so I'm no longer scared. But we will talk about the canvas most of all, because that's where a lot of the complexity actually happens, outside of literally everything else. So this is a canvas right here, and it is wrapping around a Webview area, which is this inside here, and we'll talk about that in a second. But the canvas, what it does is whatever it's wrapping around, it's actually giving it the panning and zooming behavior, and it's resizing and transforming its children. So when we're zooming, you can see that they're transform, translate, change, and the scale changes, and it's really just scaling the stuff inside. So that is the canvas, and then we're more interested in the Webview area. So let's look at that. So the Webview area has a couple components. One is this overlay, which is everything that is like displayed over is under this overlay here, and that actually ends up being quite a few things. For example, if I'm doing this, I'm drawing, and my overlay is actually drawing, and it, oops, glitch there. Like this is the overlay right here, the red part, and the stuff when I was drawing is also all on the overlay. And within the overlay, there are multiple frames that are being drawn, and the frames are this thing right here. And the reason there's multiple is because that happens, and there are now 2 frames in this frame array that we're displaying here. So let's go back to being 1 frame. Let's get rid of that guy. So let's look at this frame. This frame has a lot of stuff in it, but mostly you can think of it like an iframe. And I have deleted the wrong thing. Anyway, think of it like an iframe, and it really does function similar to an iframe, except for it has like extra functionality that we're passing into it, and you can find it right here. It's called a Webview, and this is kind of a specific Electron thing. A Webview is like Electron iframe, except for it has extra APIs that we can use. In this case, it has this preload script that we care about, and the preload script, we are adding a preload script file, and that hydrates the entire Webview with all of our functionality. And the functionalities pertains to listening to messages from the parent, the browser window, and to manipulating the DOM, such as, inserting something, deleting something, doing this buggy thing, something. So we'll just as a quick aside, where that lives is under Electron, preload, Webview. So the preload are the 2 scripts that we pass into the respective browser window. The browser view script is passed into this browser view, and that just gives it a couple APIs that allows us to have it talk to main more easily, or talk to the node process more easily. And then the Webview allows it to listen to events. It does a couple more things, like it kind of does stuff on the DOM, and it listens to events, and it mutates the DOM. So when I'm doing this, what is happening is this is sending a message inside of the Webview, and the Webview is listening to that and manipulating the DOM itself. And then separately, this is sending that change into code as well. So let's just quick look at update style. So this actually was listening to that update style event that we were sending. If I console log here, it will actually print out. Let's do update style. So if I log here, for example, if I'm popping up the width, reset everything, hot reloaded. So you see update style is being printed out because it's hearing the event coming in, and then when it does a bunch of CSS stuff based on what is being passed in right here. So that is kind of how the Webview works. So let's talk about how this whole kind of functionality work, how the browser view actually communicates to the Webview in code, not just conceptually. So we'll go back to the browser view, actually to the React browser view, and you'll see that there's a lib folder under React, and the meat and potatoes, tofu and potatoes of this lib is this editor engine. So this is kind of like the core engine of the entire editor. and is this big class that has a bunch of smaller subclasses that manage each piece of functionality. We'll look at the style manager because that's simple enough to look at. So this style manager is actually being used in the editor right here, and it is imported into the editor, and then it has this public function, update element style. If I look here, is used inside of like a bunch of the inputs. For example, the number unit input is this one here. This one here is a number in a unit. A select input is this one here. So select, and so whenever those happen, they all call this update element style function in the editor engine. And when they call it, what it does is it creates this style action, and these are defined action that is run by another process that actually handles like talking to the Webview. And why we do this like action thing is because each action we take is stored as an action and is undoable. So I just hit undo there, and redoable. And that is because they're all stored as action. So when this action gets run, let me just look at that. It runs this update style function, and it stores the action as in the history. And when it runs it, it basically just passed the object that we created previously in style into the Webview. And we remember how the Webview listens to this update style event, and that's where we printed out that log that says update style, and it takes this information, which has a selector, a style object, and the value of the style, or the style key. So this is like a CSS value and CSS key and CSS value. We can look at that and follow this channel. Find update style. So that's where it sends it. This is where it takes it. So let's just look at what it's doing with it. It has this selector that we sent, which corresponds to the element itself. And it has the property, which is the style and the value, and it's basically creating a CSS record corresponding to that selector. And that's how the styling happens. It's actually just appending to a CSS style sheet with the style we want that points to the element we want. And then separately it writes that to code. So that is kind of how the interaction between the browser view and the web view works, and how we manipulate the DOM itself. So what about code? This does stuff to the DOM, and how does that propagate into code? That is actually a very parallel process that happens when we do the styling action. For example, when we do the styling action, two things happen. One is it's creating the action, and then it's doing like committing the action in the DOM. And two is it also takes that action and it creates this other object that is a code request object. And let me just show where that happens. And I know this is very complicated, and I'm sorry. I wish it wasn't. I wish I had done a better job. But when it dispatches the action, it also calls this other subclass called code, and it also writes the action. So let's look at what that does. What it does is it queues up this action and it turns it into a code change request. And so that's too far. Let's look at where this processing happened. Execute right. So based on the object that we pass, the action, it will create a corresponding code change. So we created an update style object, and so it will create a write style action. And what this action is it is taking the changes that we've made, and it is translating that into what it looks like in code. So for example, when I make the background red, for example, it is taking this and turning that into this corresponding class name change. Okay. And you can see that here, that it's creating a selector and styles, and that's the key of the class name. And then it creates this kind of code diff request, which is really just a bunch of the changes that we have, and it is calling the main node process with this request. And in the main process, it reads in the corresponding code block, serializes it, as in turn it into, sorry, not serialize it, objectify it. So it reads the code in, it turns it into this kind of object format, JSON-ish. Well, it's a JavaScript object. And so if we just look at this, get code diff, which is kind of generating the code diff right here. What it's doing, it's processing. It is reading the code. It's calling this read file. Remember, we talked about this earlier. It reads the code block, so it actually reads just a chunk. It reads the whole file, what we call it a code block, and then it processes the file, and it walks through that object, finds the corresponding code, and mutates it, then spits back the entire change file. And so what we would get is, if go back here, what we would get is this code diffs. So let's print this out and see what is going on inside of it. Let's say I am making the background black. See if we have that print out. It might have hot refreshed. There it goes. And we did make that background black, but let's make it white. And it prints out a code diff. I should print out 2 for some reason. But let's look at this code diff. So it has a generated and original. The original is the original code. You can see there. And generated is the code that is updated very subtly. And then we take that code diff and we actually write it into code. And let's see if we really care about how that works. I have a previous video where I talk about how we actually do the mapping. Essentially, it's taking a signature of the element that is generated at build time, and then it maps that signature into the code, and we do all that processing when we generate the code diff. Let's talk about AI and chat and how that works. This confusingly is one of the simpler part of the app itself. Let's make this a little bit more visible right now. Let's make it black. Again, generate that code diff. And then we have this chat. So what the chat does is, let's say I want to turn this into a cassette tape looking diff. For example, when I send it out, you can see now it's talking, but we pass in the diff that we're looking at, and we're passing in the page, like the file, the code file, and that's why it has like this kind of information here. And oh, look at that, it turned it into a cassette tape, except for this dark part is kind of too dark. Let's make that maybe a little lighter. Grab this hex code and turn this also lighter, also lighter. Very annoying, but also lighter. And then let's make this also lighter. Just look at the code here. It generated basically a new file, and it writes that new file back into here, and it somehow has figured out that this thing is called Onlook, probably because it used to say Onlook or something of the type. I got a little too busy trying to fix this, but what it's doing, and we will take a look at that, is we look at this chat function. So this chat manager basically has a bunch of conversations, which are in themselves arrays of messages between the user and the assistant. The user is you, and the assistant is the AI, and the assistant gets to do a couple things. It actually gets to it gets to write code, whereas the user is allowed to give code. So basically, the long and short of it is, we send the user, when the user sends a message, we append that user message into the conversation. And we can see that here. I can find it. Send new message. This is being used in the chat right there when it sends your actual input. So when I send this message, I hit send, that is calling this, and it's creating my user message, which in the meantime it's also taking the context of what I'm doing, which is I am selecting this guy, and it takes that and it takes the code for that guy. It says, hey, this is what I'm looking at, this is the file, and this is what I want to do, which is what I'm typing. Then it appends it to the conversation, then it takes the whole conversation and it sends it to the LLM flavor of the day, in this case our sonnet, which is actually in the Electron process. So it sends that message into Electron right here, and then let's just, last thing, we'll just look at how Electron is handling it. So it's listening for the message, it found the message, it takes the message, it creates a model, and it streams the response back to us. So it gets past this message here, we're appending it with a system message that tells it that you are very smart, you are a very smart boy, you are a seasoned React and Tailwind expert, and it also tells it to give it in this format that we've defined, and you can go ahead and look at that format if you want, but it's essentially a Zot schema, and it says you must give it back in this format. there are other APIs, but this is the way that we're allowing us to stream. So when it is streaming, it's giving us kind of partial text string back from the stream. For example, maybe I will print this out. Partial text. And this is gonna refresh everything. I'm sorry, it's been 30 minutes. Feel free to leave in the classroom. But this is gonna cause a rebuild. So why don't we just force it to do it? I do want to show kind of what happens when it sends out a partial text. So it's sending it back a stream of a JSON object. And we are resolving that stream into a partial JSON object. And we are doing our best to not crash because the object is not complete, and when you try to serialize, to unserialize an object that's not complete, sometimes things go wrong. So we try our best to convert that back into an array of either message or code change, and then on the UI we can handle that object and display. If it's a message, then we display a message. If it is a code change, we wrap it in that nice code change like UI. So this is the code change UI, and the rest are messages, right? That's our new convo. Just say hi, make this shorter. I don't know, we just want to see the stream. So we'll see the partial stream here. It's happening. It'll say, I'll simplify the cassette tape while maintaining, blah, blah, blah. It kind of streams it like chunk by chunk, and we're kind of adding it into this full text. And then we make the assumption that it's an object, and we partially resolve it. And then when it's all done, we grab the full object and we resolve that, and then we actually commit that into the conversation. Otherwise, we have a streaming object that is being displayed as it's being streamed, and that's a conversation. So there are a lot more that is not mentioned, such as how we manage projects, how we manage persistent storage, how we have sign-in, maybe even some of the sign-in, how we're planning to do hosting, how we are creating plugins into your React projects so that they can talk to our app and allow us to understand where the code is. All that can be saved for another day. I've been talking for 35 minutes. Hope this is helpful. I'll put some timestamps down. Let me know if you have any questions. I guess email me, contact us, drop messages in the Discord, open an issue on GitHub, say hi on LinkedIn, Twitter, website. I don't know, man. I don't know. This has been fun. Enjoy the rest of your day, and see you next time. Bye.